NASA's Pilgrim 1 space mechanical assembly, the farthest journeying space mechanical assembly ever shipped off, has flabbergasted its viewers on its journey through the universe for almost 50 years. Adventure 1 has been sending back critical information from the farthest reaches of the universe, greatly advancing our perception of the cosmos. However, continuous transmissions from this astounding transport have presented bewildering signs that have left the entire space community in a state of wonder and confusion. These signs have sparked discussions about whether they are the result of a technical error or if they could indicate something far more extraordinary, perhaps extraterrestrial activity. Join us as we dive further into the mysteries surrounding these magnificent transmissions and uncover what might be hiding in the depths of space. Mankind's interest in the mysteries beyond our planet has been a primary driver in space exploration since its inception. This insatiable curiosity led to the remarkable launch of missions like Pioneer 1 and Explorer 2, which were among the most ambitious space endeavors of their time. The launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977, marked the beginning of a new era in space exploration. Just a brief time later, on September 5, Explorer 1 followed, clearing the way for an unprecedented journey. These twin spacecraft, each weighing around 720 kilograms, roughly the size of a small car, were sent on a special trajectory toward the outer planets, which played a vital role in their orbits and mission results. Throughout their remarkable odyssey, these space devices traveled in different directions and at varying speeds. A significant moment occurred on December 15, 1977, when Explorer 1 overtook its twin due to differences in their paths. Since then, Explorer 1 has emerged as a critical asset, providing significant information that has transformed our understanding of the universe and its many phenomena. Before we delve into Explorer 1's most recent amazing discovery, which has captured the attention of the entire space community, let's revisit some of its most notable achievements. In 1978, during its Jovian imaging mission, Explorer 1 was positioned around 265 million kilometers from Earth. By January 1979, it embarked on a remarkable 100-hour mission capturing a time-lapse film of Jupiter's rotation. This series of 3,750 images offered rare perspectives of Jupiter's dynamic environment and its complex features. The spacecraft's discoveries included the identification of a small ring around Jupiter and two previously unknown moons, significantly expanding our understanding of the gas giant's intricate system. To ensure the spacecraft's safe passage and avoid potential collisions with Titan, one of Saturn's moons, corrective maneuvers were performed. After the successful Saturn mission, experts decided to close the planetary missions of both Explorer 1 and Explorer 2, but the spacecraft were sent on a new course beyond the limits of our solar system, traveling at an astounding rate of 325 million kilometers per year. In January 1990, the interstellar mission began with Explorer 1 continuing its celestial journey. During this period, Explorer 1 made significant discoveries, including the identification of 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, and captured some of the most iconic images ever taken of our solar system. On February 14, 1990, at about 6 billion kilometers from the Sun, it embarked on a visual journey known as the Family Portrait, capturing stunning images of the inner planets. This collection of 60 photos added to Explorer 1's impressive portfolio of 670 photos taken during its encounter with Neptune. Explorer 2 also achieved remarkable accomplishments during its mission, recording wind speeds exceeding 13,100 meters per second, the fastest winds ever observed in our solar system. This achievement provided crucial insights into Neptune's distant atmosphere and its largest moon, Triton, whose surface temperature drops to a freezing 391 degrees Fahrenheit, making it one of the coldest places in our solar system. Triton also displayed extraordinary features, including ice volcanoes that erupted nitrogen gas and propelled frozen particles 5 kilometers into its atmosphere. These remarkable discoveries have broadened our understanding of the varied and complex nature of celestial bodies in the outer regions of our solar system. The Explorer missions have provided significant and unique results. Both Explorer 1 and Explorer 2 revealed that Jupiter and Saturn's moons, once thought to be heavily scarred and dormant, are actually active with geological processes. Explorer 2 in particular achieved several historic milestones, including being the first spacecraft to fly by Uranus and Neptune, and it remains the only spacecraft to have done so. NASA used various strategies to extend the operational lifespan of these ambitious spacecraft, including shutting down unnecessary radiators and systems to conserve energy. The mission is expected to conclude in 2030, marking a moment of pride and a hint of sadness for the researchers and engineers who have dedicated themselves to this extraordinary endeavor. The design of Explorer 1 and Explorer 2 was a marvel of engineering. These spacecraft were designed as stable platforms rotating at a rate more than 12 times slower than a clock's hour hand. This design choice reduced visual blurring as the spacecraft crossed the vast region of space. Even before reaching the outer planets, the spacecraft began transmitting images of Jupiter, revealing its swirling clouds and iconic features like the Great Red Spot, a massive storm on Jupiter that captivated audiences at NASA's Jet Propulsion Laboratory. However, the discovery of active volcanoes on Jupiter's moon Io captured the most attention. The spacecraft's instruments detected unusual signals from Io, which were confirmed by unique pictures showing towering volcanic plumes and a surface scarred by eruptions. One of Io's most prominent volcanoes erupted with a force 1,000 times greater than that of Mount St. Helens, covering an area almost the size of France. As the spacecraft continued their journey, their cameras were eventually turned off to conserve power and memory before they ventured into interstellar space. Remarkably, the images they captured did not include Mercury or Mars due to various factors. Beyond the Explorer probes, NASA has launched other prominent spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 passed Pioneer 11, becoming the spacecraft farthest from Earth. Despite the absence of other space probes to observe it, Explorer 1 continued its solo journey for 14 more years before entering interstellar space on August 25, 2012. The success of the Explorer missions was made possible through a variety of innovative techniques, with gravity assist maneuvers standing out as particularly brilliant. These maneuvers were crucial for moving the spacecraft to their distant destinations and collecting vital data. The spacecraft depended not only on their own propulsion systems, but also on gravity assists to achieve their objectives. Imagine two daring spacecraft deftly navigating through our solar system, using the gravitational pull of planets to propel themselves forward. This celestial dance allowed them to conserve fuel and achieve the necessary speeds to visit distant regions. Gravity assist maneuvers involve transferring a small amount of a planet's energy to the spacecraft as it passes by with extreme precision. For example, as Explorer 1 approached Jupiter, the planet's massive gravitational pull accelerated the spacecraft. Achieving such precision was crucial. Any deviation in trajectory or speed could have led to catastrophic results. Despite the incredible accuracy required, the brilliant minds behind these missions successfully executed these gravity assists multiple times, sending the spacecraft on an extraordinary journey. This remarkable expedition, made possible by celestial maneuvers, saw Explorer 2 using gravity assists from Jupiter and Saturn to reach Uranus and Neptune. As we reflect on the extraordinary journey of these exploratory spacecraft and the wealth of data they have provided, we eagerly anticipate further updates on the investigation into Explorer 1's latest anomalies. Both Voyager 1 and Voyager 2 continue their missions beyond known limits, and their achievements include exploring Jupiter and its moon Saturn and its moons, Uranus and Neptune. Explorer 1's time-lapse images showcase 10 eruptions of Jupiter in striking detail, including the discovery of new moons and a small ring. These discoveries have greatly enhanced our understanding of Jupiter's complex system. Explorer 1 also found 4 additional moons of Saturn: Mimas, Enceladus, Tethys, and Rhea, and took stunning photographs of Saturn and its rings, offering new insights into Saturn's intricate system. The spacecraft made history by visiting Uranus and Neptune, providing valuable data about their environments and moons, and enriching our understanding of the outer regions of our solar system. After completing their planetary missions, Explorer 1 and Voyager 2 ventured into interstellar space, gathering data on the vast environment. This ongoing investigation continues to expand our knowledge of the universe beyond our solar system. As we await more information about Explorer 1's latest signals and their potential implications for our understanding of the universe, the astounding journey of the spacecraft remains a source of inspiration and intrigue for scientists and space enthusiasts alike. Their historic achievements continue to push the boundaries of human knowledge and exploration, highlighting the boundless potential of space discovery. The Voyager missions have provided us with a treasure trove of information about our solar system and beyond. In addition to the iconic images and data, the spacecraft have also carried a brilliant record, a unique art artifact designed to share the story of our world with extraterrestrials. This record contains sounds and images chosen to represent the diversity of life and culture on Earth. It includes greetings in 55 languages, music from various cultures, and a selection of natural sounds such as thunder and whale songs. This message in a bottle, in a way, reflects the hope that one day, if intelligent life exists elsewhere, they may find and understand it, offering a glimpse into humanity's essence. Explorer 1 and Explorer 2 were equipped with scientific instruments that have changed our understanding of space. These instruments included magnetometers, plasma wave detectors, large particle detectors, and imaging systems, each contributing essential data about space phenomena. For example, the magnetometers provided insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the complex interactions between these planets and their surroundings.